Okay, this is a practice quiz for pre-calculus. It's basically section 4.1 to 4.4. They want you to convert between degrees and radians and degrees. To do so, you might use the proportion pi over 180 equals radians over degrees. Because you are given 15 degrees, the 15 is going to go where the degree goes on the bottom. So we're going to cross multiply. Get 180 times r equals 15 times pi. I'm going to divide by 180 to solve it for r. And that's going to give me an answer of, okay, when we simplify this fraction, 15 goes into 15 one time, 15 goes into 180, I think 12 times. So I hope the answer is pi over 12. We could use that proportion in problem 6, or perhaps we recognize that the pi radians is equivalent to 180 degrees, and you could just substitute it in there. So that gives me 7 times, I think that's 36. And when we do this, multiply, I hope you get 252 degrees. So that's 2 and 6. On number 9, they want us to sketch it in standard position. You always have your initial side at this point. Negative angles go clockwise. So I want to go negative 2/3 of the way here. Negative 2 pi over 3. Now I have it sketched in standard position. I think that's all that number 9 asks for. 14 wants coterminal angles. I usually ask for one positive and one negative. You can get that by adding or subtracting 360 degrees or 2 pi radians. Okay, when number 14, to find coterminal angles, I usually ask for one positive and one negative. So if you add 360 degrees, I think that gives you negative 85 degrees. So that's one coterminal angle, and it happens to be negative. If I want another one, I like it positive, I might add another 360 degrees. So if I added another 360, I think that would give me 275 degrees. Now that's positive. Hopefully I have one positive and one negative coterminal angle. Let's do the same thing in radians. Instead of adding 360 degrees, you're going to add or subtract 2 pi radians. So this is already positive, so I might have to subtract. If I subtract 2 pi is 8/4. So 13/4 minus 8/4, I think makes this 5/4. That's a valid answer. That's a positive coterminal angle. Now if I had 5/4 and I added another negative 2 pi, another negative 8/4, that would give me a negative 3 pi over 4. Now I have two coterminal angles. One is positive, one is negative. Okay, if they want us to evaluate the tangent of 4 pi over 3, pi is over here. You start here always. 4/3 is 1 and 1/3 pi. So that makes your reference angle. This part here, how much bigger than 3/3 is 4/3, and the answer would be 1/3. So I look up the tangent of the reference angle. The tangent of pi over 3, I think, is radical 3. Now in this quadrant, it is negative x, negative y, cosine, sine, alphabetical. Tangent is always sine over cosine. So if you have a negative divided by a negative, that's going to yield a positive. You don't need to put positive. If you don't put positive, I assume you mean positive. Cotangent of pi. Well, pi is over on the, if I did a unit circle, pi is over here. The coordinates on a unit circle would be negative 1, 0, cosine, sine. Cotangent is cosine over sine. cosine over sine. So the cosine of pi is -1 over the sine of pi, which is 0, making this answer undefined because you can't divide by 0. Now you have to understand when you were talking about the trigs and understand the reciprocals. Cotangent is cosine over sine, but it's also 1 over tangent. So if you multiplied top times top, and now multiply bottom times bottom, you have anything divided by itself, which should equal 1. Now on 29, we know that if you have sine squared plus cosine squared, it's going to equal 1, as long as we have the same angle. To do this effectively, you kind of have to know this trig identity. It's one of the Pythagoreans. As long as these angles are the same, which they are, sine squared plus cosine squared will equal 1. Now, over here we're finding actual values. Sine of pi over 6 is 1/2, and we have tangent squared, so I have to find the tangent of pi over 3, which I think is radical 3. When you square the square root, it goes away. 3 plus 1/2 is 3/2. I'd much rather you call it 7/2. However, I would take either of the last two answers. So you're finding values in 32 and I believe 33. You'd have to use your trig table to find some of these values. Cosine of pi over 4 is a radical 2 over 2. Tangent of pi over 4 I think is 1. And you have cosine squared minus the tangent squared. Square the top, square the bottom, that's really 1/2. Minus 1, 1/2 minus 2/2. The answer should be -1/2 for 33. Now in 38, you're going to have to use SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. This involves, for the 23 degrees, opposite and adjacent. I don't care about the hypotenuse. So the only one that uses opposite and adjacent is tangent. So tangent of theta is opposite over hypotenuse. So let's fill this in. Tangent of 23 degrees, because that's the angle I'm dealing with. The opposite is x, and I don't know why I put it over hypotenuse. What is tangent? TOA. Opposite over adjacent, I think, right? Shouldn't it be opposite over adjacent? So what is the adjacent? 100 millimeters? If you cross multiply, you get x times 1, which is just x, equals 100 times the tangent of 23 degrees. You'd have to use your calculator, make sure you're in degree mode. If you are in degree mode, we're going to get this for a result. So we get 42.447. It says to round to the nearest whole number. So that 4 is not going to round it up. If it was a 5 or bigger, it would round it up to 43, but since not, it's 42. The measurement is in millimeters, so the answer would be 42 millimeters. Now when we go to 43, we're going to do the same approach, use SOHCAHTOA. Apparently I gave you another one that involved opposite and adjacent. So to me, that's another tangent. Tangent of theta is equal to opposite over adjacent. So the tangent of what angle? 32 degrees, has to equal opposite over adjacent. Now I'm going to solve it for x. To solve it for x, I might put this over a 1 cross multiply. When two fractions are equal, you're able to do that. 1 times x is x. You cross multiply this way, you'd have 50 times the tangent of 32 degrees. Bear with me as I punch this into my calculator. I have 50 times tangent. I already verified I'm in degree mode. 32 gives me about 30. We notice it's an approximation now. 31.243. If you want to round this to the nearest whole number, I'm going to say x is about 31, and the units of measure is meters. So about 31 meters. These are a little different. I want to know what quadrant this is in. It says the tangent is y over x, or cosine over sine. Greater than 0 means that it has to be positive. So for that to occur, x and y have to have the same signs. So that works in quadrant 1, that works in quadrant 3. The secant is 1 over cosine. Greater than 0 means positive. That means that cosine, which is also the x, alphabetical cosine sine, the x has to be positive. So the only place that occurs is in quadrant 1. We're just identifying the quadrant on this problem. The next one we'll solve. 49, they give us the cosine to be 2/5, and they say the sine is again the y value, less than 0 means negative. So the y has to be negative. For the y to be negative, that's in quadrant 3 or quadrant 4. Now the cosine is the x, so x has to be a positive 2/5. For the x to be positive, it has to be in quadrant 4. 3 would have a negative x value. So when I graph it, I'm going to go put it here. I know it's not to scale, but this is going to be a 2 and a 5. Bear with me a moment. Okay, I'm not positive of those, so I'm going back. I just want to talk a minute. I do want to have the triangle in the quadrant that I stated. There's your right angle. Cosine is adjacent over hypotenuse. SOHCAHTOA. So the adjacent is 2, the hypotenuse is 5. If you do Pythagorean theorem, 2 squared plus y squared equals 5 squared, you're going to get 25 minus 4, 21. So you're going to get radical 21. But I believe it's negative in this quadrant. The y has to be negative. Now if they give us the cosine to be 2/5, you should know the secant is its reciprocal, 5 over 2. Now from other ones, sine is opposite over hypotenuse. So opposite, here's my angle, opposite is this over hypotenuse, 5. Tangent is TOA, opposite over adjacent. Opposite over adjacent, which is 2. Opposite over adjacent. Now when you do the reciprocal, you get 5 over negative radical 21. When you rationalize it, you'll get this. When you flip this over, you'd have a 2 over a negative radical 21, which when you rationalize it, I hope becomes these. Anyway, we'll have all of our trig values. Now we want to find these trig values now, a sine of 240 degrees. If I go over to here, that's 180 degrees. This would be 270. I don't want to go all the way to 270. I want to go to 240. Now I look at my reference angle. So I find my reference angle, which is this. To the x-axis, reference angle goes from the terminal side to the x-axis is always acute. 240 minus 180, I think, leaves me with 60 degrees. So I use that as my reference angle. So I look up the sine of 60 degrees. Sine of 30 degrees is 1/2, so I'm assuming sine of 60 degrees is radical 3 over 2. In this quadrant, it's negative, negative, cosine, sine, so the sine of the sine should be negative. Okay, for number 58, I want to use a tangent of 120 degrees. All the way over is 180. I don't want to go quite that far. I want to go to 120 degrees. What does that leave for my reference angle? I think 60 degrees again, right? So I look up the tangent of 60 degrees, the tangent of the reference angle. The tangent of 60 degrees, I think, is just radical 3. In this quadrant, it's negative, positive. Always alphabetical, cosine, sine. Tangent is sine over cosine. So what's a positive over a negative? Hopefully this answer is a negative radical 3. Now 67, you have angles that are negative. Here's your initial side, always in the same position. Negative angles go clockwise. So let's see, 6 goes into 35 how many times? 5 with 5 left over, I think. So I want to go negative 5 and 5/6 of pi. So if I'm going negative 1 pi, negative 2 pi, you'll notice the evens are on the right, the odds are on the left. So I have to get all the way to negative 5, so there's negative 3 pi, negative 4 pi, and all the way over to here is going to be negative 5 pi. Then I want to go 5/6 of a half revolution, so 5/6 over here. So I have negative 5 and 5/6 pi, leaving me a reference angle of 1/6 pi. So I look up the cosine of 1/6 pi, which is radical 3 over 2 on my trig table. And in this first quadrant, everything's positive, so the result should be radical 3 over 2. I hope these help. This is just to help prepare for the practice quiz. This is a practice quiz to prepare for the quiz coming up on 4.1 to 4.4 in pre-calculus course. Good luck.